Okay, a sequence. A sequence is a set of numbers separated by a comma in which each number after the first is formed by a definite rule. So each number in a sequence is a term of that sequence. The first number is the first term and is denoted T1. Similarly, the second term is denoted T2 and so on. Tn represents the nth term. So for example, 3, 5, 7, a line, we can see it's gone up in twos. T1 is the number 3, T2 is 5, T3 is 7, T4 is 9. Okay, these are the terms of the sequence. You can also use U1, U2, U3 and U4. U is also allowed to be used. Okay, so example 3, 7, 11, 15. Okay, each number after the first is obtained by adding 4 to the previous number. In this example, 3 is called the first term, or T1, and second term. And in this sequence, you're going 1, 3, 9, 27. Each number after the first is obtained is multiplied by the previous number. So the previous number by 3. So 3 times 1, 3. 3 times 3, 9. 3 times 9, 27. In this example, 1 is called the first term, 3 is the second term, and 9 is the third term. Okay. What we can sometimes have is a UN representing a formula. Okay. So for example, in the last book we had an equation un plus 1 equals 2un plus 4n. In this case, un represents the nth term. While un and tn are usually interchangeable, it is not unusual to see reference to u0 after some circumstances, the expression for un. So an example would be example would be this one here. Okay, you could say un equals x to the n. Okay, and n is greater than 0. Okay, so that means that you have to start off at n equals 0. Okay, so sometimes you might actually have a u0 as your first term. So u0 is x to the power 0, which equals 1. u1 is x to the power 1, that also equals 1. Well, to do that for tn, you'd have to, where n is bigger than 1, you'd have to say that T1 is going to be x to the power 1 minus 1. So you have to do this 1 minus 1 business to get your x0, which equals 1. That's when explaining this sequence here. So you can see that it can be written, sometimes your first term can be u0, or sometimes your first term can be T1 or u1. So the question itself will let you know what you're doing. Okay, so now we're going to move on to some questions. Part 1. If un is n squared plus 5n, find u1, u2 and un plus 1. Well, to get u1, just replace n with 1, and what we're going to get here is obviously going to be 6. Okay, and then in the second one we're going to say u2, and in this case u2 is going to be 2 squared plus 5 times 2, which is going to be 14. Okay, once again, very easy. And then finally u of n plus 1. Well, to find u of n plus 1, replace n with n plus 1, because n is here but n plus 1 is here. So we're going to have n plus 1 squared plus 5 times n plus 1. We're going to square all that out. N squared plus 2n plus 1 plus 5n plus 5. And then we're going to get n squared plus 7n plus 6. Okay, so there we go. Now we have our next question. Okay, and then part 3, it says if un is 66, find the value of n. So un is n squared plus 5n. N squared plus 5n equals 66. Bring the 66 over to your side, you're going to get n squared plus 5n minus 66. We're going to have a reference number of minus 66. We're going to solve it, and what we're going to say is that it's going to be n plus 11, n minus 6 equals 0. And then we're going to say that n equals minus 11 or n equals 6. Okay? And then, but what we need to realize is going to be basically it can't be a negative answer. N can only ever start off as 0 or 1, so the answer is going to be n equals 6. It's the 6th term. Okay. Now, if show that u of n plus 1 is bigger than un. So we're going to take our u of n plus 1 answer from earlier, and we need to prove that it's bigger than un. So what we have here is u of n plus 1, which is n squared plus 7n plus 6. That's what u of n plus 1 is. And then we're going to show that it's bigger than un. And un is basically n squared plus 5n. Cross off the n squareds, then bring the 5n over to your side and take it away, and we're going to get 2n plus 6 is bigger than 0. Has to be bigger than 0 because n has to be greater than or equal to 0. Okay, so that's question 3. Moving on to question 7. Okay, so it's a proof question. So what we have to prove is that if un is n plus 1 by 5 to the power of n, proof that un plus 2 minus 10 un plus 1 plus 25 un equals 0. Okay, so what we're going to have to do is find out what u of n plus 1 is starting off. U of n plus 1, so we're going to replace n with n plus 1, and now it's going to turn out to be n plus 2, and that's going to be 5n plus 1. Now n plus 2, 5 to the power of n plus 1, if you remember your power of indices where it have ax plus 5 for example, that equals ax multiplied by a5. Okay, in the same way 5 to the power of n plus 1 is going to be 5 to the power of 1 multiplied by 5n. Now I can multiply 5 by n plus 2, and what I get is 5n plus 10 multiplied by 5 to the power of n. Okay? Okay, so that's 5n plus 10 power 5n. Okay, and then the next part is u to n plus 2. Okay, this time we're replacing n with n plus 2. So we have n plus 2 plus 1 in the brackets, so that's going to be n plus 3. Then we have 5n to the n plus 2. And 5n plus 2 is the same thing as 5n by 5 squared, which is 25 times 5 to the n. So what we're going to have is n plus 3 multiplied by 25 multiplied by 5 to the power of n. Multiply by 25 in there, and we're going to get 25n plus 75, and then in brackets 5 to the power of n. Please remember, the only reason we're not multiplying that out yet is because of the indice. Okay, now we know what un plus 2 is, we know what u of n plus 1 is. Now we got to go to our formula. Okay, so what we're going to do here is just make this a bit smaller and start using the results. So u of n plus 2 is 20. We're going to multiply it out at the same time. It's going to be 25n by 5n. Okay, and then it's going to be 75 plus 75 multiplied by 5n, and then it's going to be minus 10 un. So minus 10 un is going to be minus 10 times 5n plus 10, 5 to the power of n. So what's going to be is, that's going to be minus 50n minus 100, and all of that is going to get multiplied by 5 to the power of n. Then we just rub that part out, and then what we're going to get is minus 50n 5 to the power of n, and then minus 100 5 to the power of n. Okay, so now that this is done, what we gotta do next is we gotta fix up 25u to the n. Now 25u to the n, so we know that un is n plus 1 times 5 to the n. Okay, so just make this just drag this over, make it slightly smaller. Okay, so we next have to do 25u to the n. So multiply n plus 1 by 25, and you're going to get 25n plus 25, and this is going to be multiplied by 5 to the power of n, and that's going to give me plus 25n 5 to the power of n, and then we're going to have plus 25 5 to the n. Now look at each terms, the terms, and we have to prove that all equals 0. So what we have here is 25n plus 25n minus 50 is 0. Okay, or you could also you could just say 5n multiplied by 25n minus 50n plus 25n. Okay, and that all goes to 0. Okay, so 0 times 5 to the n is 0. And then finally we're going to have 75, 5 to the n. So it's going to be plus 5 to the n multiplied by 75. And then we have minus 100 plus 25. And we can see that that also cancels to be 100 minus 100, which is 0. So we just have to prove that the answer is 0. Okay, so that's numbers 3 and 7 completed. Now we're moving up to number 12. Okay, so number 12 is going to be if u to the n is 4n plus 1 factorial. Show that u to the n plus 1 minus n u to the n equals 2un. Okay, so this is a reasonably difficult question. Now let me show you what factorial means. Okay, factorial means 5 factorial basically means 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. 4 factorial is equal to 4 multiplied by 3 multiplied by 2 multiplied by 1. So what I can always rewrite is that 5 factorial equals 5 multiplied by 4 factorial, because if I added in the extra 5 multiplied by 4 factorial is the same thing as 5 factorial. So any number, so for example 10 factorial is the same thing as 10 multiplied by 9 factorial. 100 factorial is the same thing as 100 multiplied by 99 factorial. An example n factorial would be the same thing as n multiplied by n minus 1 factorial. Just the same number with the one number smaller beside it as the factorial. So I think that might come in useful here. Okay, so first of all we have u of n, which is here. Now we're going to find out what un plus 1 is, and un plus 1 is basically going to be replace all n's with n plus 1, so we're going to have n times n plus 2 factorial. Okay, so it's going to be 4 times n plus 2 factorial. Now what we're going to show is that this one minus this one equals 2u to the n. So n plus 1 factorial is 4 times n plus 2 factorial. Okay, and this is going to be minus n times 4 multiplied by n plus 1 factorial. And I have to show that equals 2un, so multiply this by 2 and I'm going to get 8 times n plus 1 factorial. So remember what I said last time. N plus 2 factorial is going to be the same thing as n plus 2 multiplied by n plus 1 factorial. Okay, so it's going to be 4 times n plus 2 multiplied by n plus 2 factorial. Okay, multiply that out and you're going to get 4n plus 8. 4n plus 8 n plus 2 factorial minus n multiplied by 4 is 4n n plus 1 factorial, 4n times n plus 1 factorial, and we have to prove that that equals 8n n plus 1 factorial. So we just got to factorize this out here, and we're going to get is, oh sorry, that's n plus 1 by the way, we changed that into n plus 1. It's 4 times n plus 2 times n plus 1 factorial, and then it's going to be if we factorize out n plus 1 factorial, what we're going to get in the brackets is 4n plus 8 minus 4n, and we can see that they cancel, and we're just going to get 8 times n plus 1 factorial also equals 8 plus n plus 1 times factorial. So that's proven. Okay, so that's number 12 done. Now 15. If tn equals 1 over 2 to the power of n, show that t of n plus 1 is less than tn. Okay, so show that t of n plus 1 is smaller than tn, where n is element of n. So n element of n means it's going to be 1, 2, 3, all the natural numbers. Okay, going above. and if Tn equals 1 over 2 to the power of n. Okay, so what we're going to do is we're going to find out what t of n plus 1 is. T of n plus 1 is equal 1 over 2 to the power of n plus 1. Now remember, 2 to the power of n plus 1 is basically 1 over 2 to the power of n by 2 to the power of 1, or it's 1 over 2 times 2 to the n. Okay, same thing. Now we have to prove that this is smaller than 1 over 2 to the power of n. Now what you got to remember is when you're changing these across, okay, what you have to remember is that basically you can only cross multiply a positive number. So for example, if a third is, I don't know, less than a half, if this is a positive number, what we're going to get is 1 is less than 3 over 2 when you cross multiply it. However, if you had 1 divided by minus 3, or basically minus a third, and we know that minus a third is smaller than is a smaller number than minus a quarter. And once again, the minus a quarter, we're going to put the minus emphasis on the minus 4. What happens is basically when I cross multiply this time, what happens is I'm going to get 1 is less than minus 3 over minus 4, and 1 is less than 3/4, and we know that's false. But that's the difference between it working for a positive number and not working for a negative number. Now what we can be assured is that 2 to the power of n is definitely a positive number, so we can just cross multiply it. Okay, so we're going to get a half is less than 2 to the power of n over 2 to the power of n, and what we get is a half is less than 1, and this is true. Okay, so we know that Tn is smaller than Tn plus 1. Okay, yeah. Okay, so this one here is show that Tn plus 1 is less than Tn. So what we're going to do is we're going to replace n with n plus 1. So this n turns into an n plus 1. And now we're going to have n plus 4. The bottom one is going to be 2 times n plus 1, which is 2n plus 2. This 2n plus 2 gets added on to the 1, then comes 2n plus 3. Now, what we can see here is that we want to show that Tn plus 1 is smaller than Tn. Okay? So Tn being 2n plus 1. Oh, sorry, n plus 3 over 2n plus 1. Now once again, all of these denominators are positive because n has to be bigger than 0. Bigger than 0, not bigger than this, equal to bigger than 0. So all of these, this number has to be a positive one, and this one has to be a positive one. So we just cross multiply, and we get 2n plus 1 multiplied by n plus 4 is less than 2n plus 3 multiplied by n plus 3. Let's multiply these out. We're going to get 2n squared. We're going to get 8n. We're going to get 1n. Then we're going to get 4. Then it's going to be less than 2n squared plus 6n. Or sorry, 6n plus 3n plus 9. And what we're going to get is 2n squared plus 9n plus 4 is less than 2n squared plus 9n plus 9. And what we can do is we can cross off both sides, and what we can get is 4 is less than 9. This verifies that this is once again true. Okay, and that's question 16 done.